Okay, so today's class is going to be on fetal membranes and placenta. And basically, we're going to look at the development of placenta, since we've all done the development of the fetus itself, okay, with Dr. Reshma. So we're going to focus on the placenta now. How does it develop from the cell that it came to be after fertilization, and how it's going to be able to support the fetus, how it's going to have the maternal and fetal blood that will give the exchanges, okay, gas exchange, nutrient exchange, metabolite exchange, right? So we're going to look at the development of placenta, and then we're going to look at what does the full term placenta look like, all right, and the function of the placenta in general. Um, as well as we're going to talk about the placental circulation. Okay, so what is the fetus circulation like? What will be the maternal circulation like? And hope you know that the maternal and fetal blood does not mix. Okay, the maternal and fetal blood will not mix. Instead, there will be a barrier called the placental barrier that will keep these two circulations separate. So the fetal circulation will be separate from the maternal circulation. Okay, and then we're going to talk about the amniotic fluid, okay, the function of the amniotic fluid, um, the umbilical cord itself as well. And lastly, we'll be looking at the abnormalities of the placenta, the umbilical cord, amniotic fluid, and what kind of clinical condition that is derived from these abnormalities, and what could happen to the fetus. Oopsie. Okay, so my want to share the screen and hopefully.
Excuse me, doctor.
Yes.
Actually, today MO4 is supposed to give a short taskira, a short talk before the class begins.
Oh, okay. All right. So usually you'll start that off first. Okay, never mind. You'll do that first.
Okay. All right. Okay. So first of all, good morning, Dr. Sarah and my fellow batchmates. My name is Suhash, and I'm from Group MO4. And today I'll be giving a short talk about stress management. As you all know, we have already studied about stress management during behavioral science, and we all know a thing or two about managing stress. So today I will just make a quick recap about stress and give a few extra tips on managing stress. So medical students in general, let it be first year students or fifth year students, we all have to navigate all the ups, downs, and long hours of studying and training to become a good doctor. In some cases, a rigorous school schedule and other demands can sometimes take a toll on medical students' mental health. According to an analysis in the Journal of the American Medical Association, nearly 30% of medical students suffer from depression or have symptoms of depression. That is significantly higher than the 9% of the general population that suffers from depression, according to the National Institute of Mental Health. Stress can be caused from a variety of sources, but in my personal opinion, I would say that the main cause of stress for medical students is the pressure to succeed in university and keep up with our classmates. Especially when it comes to our parents, who constantly pushes us and expects us to do our best and be in the top of our class in every semester. Some other common sources of medical school stress can be lack of sleep due to time spent studying or limited time for relaxation, meaning the students they only know how to eat, study, sleep, and repeat. Realistically, nobody's day is completely stress-free, as stress is something inevitable or unavoidable. However, too much of it can interfere with a student's ability to stay focused on studies. Some of the signs that a student may be overstressed are the students start experiencing anxiety, depression. They also start to binge eating and excessive alcohol use. And they also have trouble sleeping at night and experience insomnia. So there are plenty of easy, healthy, and fun ways to deal with stress in medical school. First and foremost, I would say exercise. So exercise can be an excellent way to de-stress. As you all know, UOC offers a wide range of sports and extracurricular clubs for students to participate, such as volleyball club or Persatuan Silat, as well as a functional gym for students to use. Unfortunately, since our studies are online for the time being, we are unable to access these facilities and participate in most of the extracurricular activities. However, this shouldn't stop you from exercising at home, as you can go for a jog, or you can cycle around your neighborhood, or you even can play sports such as futsal or badminton with your friends and family. But be sure to follow the SOPs, especially in areas that are under the conditional movement control order, to avoid spread of COVID-19. Combining exercise with healthy sleep and eating habits also goes a long way in dealing with stress, especially in medical school. Starting with that healthy baseline will put students in a much better place if stress becomes intense. Next, maintaining a strong support network or taking time to socialize are also crucial. Students are encouraged to cultivate meaningful relationships, whether it's with a classmate, family member, or even a workout buddy, especially while they're going through difficult periods of education and training. Socializing does not mean that you have to be around with a huge group of people, because sometimes being around with a large group of friends who you feel uncomfortable is actually more lonely than being alone by yourself. Just having a small circle of friends or close family relatives is actually more than enough, as long as you have someone who supports your back, is willing to lend their ears and give you advice when you are feeling rock bottom. So as a conclusion, a small measure of stress is realistic and is often helpful when training to become a good doctor. A healthy amount of stress can keep students engaged at an optimal level, sharpening their attention and allowing them to perform their best on tests and in the clinic. Some pressure to perform is absolutely necessary, because one day all of us, we are going to be doctors who are going to be in operating rooms and emergency rooms, and we are going to make a lot of high-stake decisions. Therefore, we have to be the kind of individuals who are resilient and can deal with stressful situations. I believe that if there are successful doctors out there who can do it, so can we. Because at the end of the day, there are no great people, only great challenges which ordinary people rise to meet. So that is all from me. Thank you, and I'll pass it back to Sarah.
Okay, thank you very much, Raj. Hopefully, you all can take that as good advice, and hopefully, we can all follow it to some extent. Okay, so back to your stressor, which is embryology. Okay, today, as I mentioned, we're gonna continue on with your embryology lecture. Okay, and you've done all the what do you call that? The development of the fetus, okay, the embryo and the fetus. So now we're doing the development of the placenta. So placenta will be the structure that will support the fetus. All right. Now, if we just go back to um, fertilization. Okay, so fertilization, I hope you still remember what Dr. Rishma taught you. So fertilization occurs when the ovum or the secondary oocyte, uh, to be exact, is fertilized by the sperm. Okay, so after fertilization occur, you get what is known as the zygote. Okay, so zygote is when just after the fertilization occurring, you have a zygote that will also divide into the two cell stage zygote. Okay, and it will continue to be continue to divide, and eventually it will become a 16 cell stage product of conceptus, and this is known as, okay, so I'm just gonna go. This is known as morula. Okay, remember morula? Yeah, it's all supposed to be circle in shape. Okay, they all have this ball of cells, 16 cells, and eventually it'll become morula. And it will divide further, and then it will also go through compaction, division, cleavage, and eventually it will form this ball that will have two distinct layers. Okay, and you have a space in between the two distinct layers. So you should know all this. The one on the inside here is known as the inner cell mass. Okay, and the inner cell mass is going to be the embryoblast. Embryoblast. Okay, so this embryoblast will eventually give rise to the embryo. So every one of us is going to derive from this inner cell mass, right? All of our cells were once originally from the inner cell mass. And that will undergo, gastrulation, will become your bilaminar, trilaminar disc. So you have your endoderm, mesoderm, ectoderm, everything else, everything of that, of what you've learned about embryology will be from the embryoblast itself. Now, on the outside here, okay, there's another layer of cells here, and this here is known as your outer cell mass. Okay, outer cell mass. So outer cell mass also known as trophoblast. Okay, trophoblast. And this trophoblast is where the placenta will eventually arise from. Okay, it will give rise to not just the trophoblast, of course, it will differentiate and it will have different layers. And that is where the original supporting structures, like supporting cells that will support the embryoblast as it will grow and grow to become an embryo eventually. Okay, and eventually, okay, what will happen, right? So you have this inner cell mass which will do its thing. Okay, so you've read about that, you've learned about that, what the inner cell mass will become and how it will grow. Okay, the outer cell mass, meanwhile, okay, this is an easy way to draw it. Okay, we'll just have curly hair all around it. So the outer cell mass, it will continue to grow as well. So it will continue to grow, it will become multiple layers. Okay, and eventually the layer that is on the outside, okay, so outside here will have a layer of cells. So these cells here on the outside will lose its cell wall. Okay, the walls on the outside, on the outer part of the cells will disintegrate. So the cell wall will disintegrate. Now what it will become is it will become this mass of cytoplasm. Okay, so all the cytoplasm will join together. The cell wall will disintegrate. You still have many nucleus. It will be multinucleated mass of cytoplasm. Okay, so I'll just draw it somewhat like that with nucleus everywhere, but no cell wall. And this layer, it will differentiate to become as such. Okay, so now all of this, so you have this one was your embryoblast, okay, on the inside. So we'll just highlight that in yellow. Okay, and then the green was your trophoblast. Now that the trophoblast has these two layers, one with cell wall and one without its cell wall, it will have different names. Okay, and on the outside here will also have a different name to it. Okay, so what used to be one layer of trophoblast has now divided and differentiate itself to become the inner part will be known as cytotrophoblast. Okay, cyto, okay, cyto means cell, so you can see the cell is all very much intact still. So that's your cytotrophoblast. And then on the outer part, okay, the red colored layer, which now has no cell wall, so it's just a mass of cytoplasm that is all clumped together. This is known as syncytiotrophoblasts. Okay, so embryoblast will do its thing. We're not gonna talk about it. We're not gonna explain how this mass of cells will become a very complex human being. But we're gonna be concerned about this layer here. Okay, this cytotrophoblast and syncytiotrophoblasts. Okay, so this is what we're going to be talking about today. Now, I'm just going to stop there at the moment, and we'll talk about the place where all this happens. So, do you know your uterus? Okay, so uterus is all of the fertilization will occur. I hope you know that the fertilization will occur at what is known as the fallopian tube. Okay, so it will occur right at the end of the fallopian tube, and as all this happens, all right, this the product of conceptus will be moving along the fallopian tube and going towards the uterus. Okay, so go from the outside here. From the outside, it will go slowly into the nearer to the uterine cavity. Okay, so now we're going to be looking at the uterus here. Okay, so the uterus, this area here, okay, you have three layers to your uterus, right? You have your, so if I just take out this and draw it like that, okay, so you have three layers to the uterus. Okay, on the outside here, you have what is known as the perimetrium, okay, and then you have a layer of what is known as myometrium. Okay, myometrium means muscle. Okay, so there's a muscle layer of the uterus. On the outside, this is the covering of the uterus, and on the inside here would be the endometrium. Okay, and the endometrium is the one that will proliferate during menstrual cycle. During the cycle, it will proliferate and it will slough off to become menstruation. Okay, so the endometrium here is very important. Now, we're going to talk about this because part of the endometrium actually will contribute to the formation of the placenta. Okay, so part of it will be from the endometrium, part of it will be from the embryo itself, will be from the product of conceptus itself. Okay. Now, during when fertilization all occurs, you're all in this in the menstruation cycle. Okay, and this menstruation cycle, at the point of the menstruation cycle, the uterus is what is known as a secretory phase. Secretory phase. That means the endometrium is thick. It's very vascular. Here you see a lot of glands in the endometrial layer. Okay, so this all is the secretory phase of your endometrium is going to be because the corpus luteum is still producing progesterone. So it helps to maintain the thickness of the endometrium, the vascularity of the endometrium. Now, talking about the endometrium will also have three layers. Okay, so you have the outer part, okay, the most the one near the endometrium, and the one near the myometrial layer, and then you have uh, the second layer, and then you have a third layer. So all of this layer also has a name. Okay, so the layer that is nearest to the myometrium is called the basal layer. Okay, and then you have the spongy layer. Okay, and the one nearest the uterine cavity is called the compact layer. Okay, so all of these three layers, only these two layers is called the functional layer of the endometrium. Okay, functional layer is because the spongy and compact layer is the one that will proliferate, that will become bigger, that will slough off. The basal layer will remain. Okay, basal layer will remain because you always need to have a layer of cells that will keep dividing, that will replenish the other two layers, the spongy and compact layer. Okay, so we're talking about the functional layer of the endometrium. We're talking about the spongy and compact layer of the endometrium. The basal layer will always remain along the myometrium and perimetrium to ensure that the endometrium will always have a constant supply of cells that will divide and proliferate and will replenish the spongy and compact layer. Now, during the secretory phase of your menstrual cycle, okay, during the secretory phase, these two functional layers, the compact and the spongy layer, will become very vascularized. Okay, so you have a lot of vessels, and also it will be very glandular, as mentioned. All right, so you have a lot of blood supply, and it will have a lot of glands also. And all of this will help to ensure that the endometrium, okay, the functional layer of the endometrium is in its best or its most optimum phase to receive the implantation of the product of conceptus. Okay, so it will be it will be highly vascularized. It will have a lot of glands, and also the cells itself will have what is known as will have a lot of storage of lipid and glycogen. Okay, so all of this will ensure that you have enough nutrients to support any incoming product of conceptus. So this functional layer that is now very thick and very vascularized will be supported, as mentioned, by the corpus luteum, which produces progesterone. Okay, but if you still remember, the corpus luteum, it does not last a long time. The corpus luteum maybe lasts about 10 or to 12 days after the formation of corpus luteum. So after you have your ovulation, the corpus luteum will be maintained for 10 to 12 days, and eventually it will regress, it will degenerate, and it will die. Okay, so in normal in a non-pregnant state, okay, if you don't have any fertilization occurring, so as the corpus luteum regresses, then you will get your functional layer of endometrium that will slough off and it will begin your menstruation. But in pregnancy, what happens, okay, after fertilization occurs, something needs to tell the corpus luteum to keep on producing progesterone to ensure that the functional layer of the endometrium will continue to grow or to have this vascularity and glandularity that will support the implantation of the product conceptus. So what happens is that this this structure here, the product of conceptus itself, will secrete HCG. Okay, so HCG. What is HCG? HCG is human chorionic gonadotropin. Okay, and which layer of your blastocyst that will secrete HCG is the syncytiotrophoblasts. So the syncytiotrophoblastia will produce HCG, and this HCG will go to your corpus luteum to tell your corpus luteum, hey, don't die, please continue to produce progesterone so that you can support myself. Okay, you can support the product of conceptus to embed in the uterus itself. Okay, so once that happens, once the corpus luteum gets a signal from HCG, the corpus luteum will change its name from a simple corpus luteum to corpus luteum of pregnancy. Okay, so once corpus luteum is under the influence of HCG that is produced by the syncytiotrophoblasts layer, okay, it will change its name to become corpus luteum of pregnancy. So the corpus luteum of pregnancy here will produce a lot more progesterone to ensure that the functional layer of the endometrium is maintained. Okay, and also it will give off, it will ensure that the functional layer becomes more vascularized, more secretory, and the cells will further enlarge to ensure that you have a lot of storage of lipid and glycogen. Okay, so as all this happens, right, the functional layer of the endometrium, okay, which is your spongy and the compact layer, will undergo what is known as decidual change. Okay, decidual change occurs when it is under the influence of the corpus luteum of pregnancy. It will become more vascularized, okay, more secretory, okay, so you have a lot more granular, a lot more glands in the area, and all the cells will become enlarged with storage of lipid and glycogen. So this is much more so than when it was just under the influence of the progesterone from the normal corpus luteum. Okay, now that it's under the influence from the corpus luteum of pregnancy, it will become more vascularized, more glands, more storage of lipid and glycogen, and all of this will be known as decidual change of the endometrium. So now the functional layer, the compact and spongy layer, is now known as decidua. Okay, so once it undergoes this decidual change, you now call it decidua, and we'll come back to what decidua is, the different types of this decidua that you have, in a bit. But now we're going to have to go back to the product conceptus. Okay, we're going to look at the human embryo and the various changes that will occur now. So what the villus that will occur, the villus that will form, okay, the lacuna, how it's going to get your blood supplied and everything else. Okay? All right, so let's move on. All right, so now we're gonna draw the embryo again. Okay, so in you have the embryo. Now that is going to not just become the embryoblast. Okay, you're gonna have a bilaminar disc now. Let's see what color shall we do. Just do blue. Okay, so that's your bilaminar disc. Okay, I'm just going to draw this first, and then we'll be talking about what all these structures are. Okay, so you have the bilaminar disc of the embryo. That's your bilaminar disc. Okay, and then in green here, that's your amniotic cavity. And then you have your yolk sac. Wait, okay, yolk sac is there. So this is here will be the chorionic cavity. Right. Now in black here would be your cytotrophoblasts. Cytotrophoblasts. Okay. And also you have the syncytial. Okay. Syncytiotrophoblasts. Basically what happens is this part here, okay, has grown and will differentiate to become your bilaminar disc. Okay, and it will give off also the amniotic sac, amniotic cavity, and the chorionic cavity. Okay, this all will differentiate. So as this happen, all right, as this happen, the syncytiotrophoblasts will surround the embryo proper. Okay, and in the syncytiotrophoblasts, the cells of the cytotrophoblasts will proliferate. Okay, and it will form all these projections into the syncytiotrophoblasts. So all these projections will be occurring everywhere. Okay, all of it will be occurring everywhere, and this is called what? And this projection is known as primary villus. Okay, so primary villus will occur not just at the embryonic pool, but it will occur everywhere around your embryo. It will be made up of a projection or a core of your cytotrophoblast through the syncytiotrophoblasts. Okay, so if I were to say what is primary villus will be a core of your cytotrophoblast, and surrounding it will be the syncytiotrophoblasts. Okay, that's why it's known as primary villus. Okay, that's your cytotrophoblast, that's your syncytiotrophoblasts. So all of these trophoblasts, all of these villus, okay, will be surrounding the embryo. And then what happens in the syncytiotrophoblasts, you'll find that you have uh, spaces occurring around, okay? Spaces here occurring in between all your primary villus, okay? And this here is known as lacuna. I don't think you can see that. I'll just write lacuna, okay? And eventually these spaces will coalesce with one another. Coalesce means that it will what it will be continuous with each other. Okay, so you'll form continuation between one villus and the other, and therefore it becomes your lacuna system. So it becomes more of a system. Okay, so now you have your primary villus and you have your lacuna system surrounding your primary villus. What happens as well is that the syncytiotrophoblasts, apart from it producing a lot of HCG, you also have the syncytiotrophoblasts producing a lot of materials or a lot of molecules that can degrade vessels. Now, these structures here is going to be implanted in the uterus, okay? And as it implants in the uterus, as I mentioned earlier, your uterus has a lot of blood vessels, okay? So it becomes very vascular. So you have a lot of blood vessel around, Okay, you have arteries, spiral veins in your endometrial layer. So what happens is that the syncytial trophoblast will erode. Okay, it will produce molecules that will erode the wall of the blood vessel. Okay, so it will erode the wall of the blood vessel. So now what happens is that you have an opening to the blood vessel that would give off blood into the Lacuna system. Okay, so now blood from the artery, the spiral arteries of the maternal circulation will leak into the Lacuna system. Okay, so you have a lot of maternal blood in your Lacuna, and eventually the blood will then return back into the veins of the maternal spiral veins. Okay, so now you have this connection. You have this pooling of the maternal blood from the spiral arteries and spiral veins of the endometrium into the embryo. So this is going to be the start of the maternal circulation in your uh, formation of the placenta. All right. Okay. Now we're going to move on to further formation of the embryo. Okay. So if I just draw this again. Okay, bilamina layer, bilamina disc, and then you have the amniotic cavity, and then you have your chorionic cavity. Okay, wait. This one here is not yet the chorionic cavity. This is the yolk sac actually. This is the yolk sac. Sorry. So that's the yolk sac. That's your amniotic cavity. Okay, you have your bilaminar disc, and then you have your cytotrophoblast surrounding the embryo proper. Okay, cytotrophoblast and your syncytiotrophoblast. Along with it, you have a lot of your primary villus in there. Okay, primary villus will occur everywhere. Okay, and also in between the primary villus, what will you have? You have the lacuna. So now the lacuna will be continuous with each other. Okay, not all, but you have this system. Some lacuna will be big, some lacuna will be small. Okay, so you have the lacuna everywhere, and this will be where you find your maternal artery in maternal blood vessel in there. So now what happens is that the yolk sac here, okay, this yolk sac is obviously going to be lined by cells. Okay, so now the yolk sac cells here will produce, okay, will produce what is known as extra-embryonic mesoderm. Okay, so this yolk sac cells will produce a connective tissue known as mesoderm. I hope you can still remember in our lecture of connective tissue. Okay, embryonic connective tissue, you have mesenchymal and mesoderm. So this will produce, the yolk sac cell will produce mesoderm, and it will produce a lot of mesoderm that it will cover the whole of, it will surround the whole embryo proper. Okay, so you have a lot of this mesoderm that will be in between the yolk sac and the cytotrophoblast, and will also proliferate in between the amniotic cavity and the cytotrophoblast. Okay, so it will go everywhere surrounding the embryo. This here is your mesoderm. Now this mesoderm, you don't confuse it with the mesoderm that is going to be produced by the disc itself, by the embryo itself. Because in here, you will also produce mesoderm, but that is known as intra-embryonic mesoderm. It's not part of this structure. It's not going to be the same as the one on the outside here. This one here is your extra-embryonic mesoderm that is going to be produced by the yolk sac cell. Okay, so the yolk sac cell will produce a type of connective tissue known as extra-embryonic mesoderm. Now, what will happen is that in your extra-embryonic mesoderm that is deposited outside the yolk sac, okay, it will deposit outside the yolk sac, but inside the cytotrophoblasts. Okay, so now what will happen is that eventually there will be what do you call that? Spaces. There will be spaces that will occur in between in between the extra-embryonic mesoderm. So there will be spaces that occurs, and this space is called coelom. Okay, so there will be a space there, there will be another space there, there will be another space there, there will be another space there, and these here are all called coelom. Okay, and all of this coelom, okay, the extra-embryonic coelom will eventually coalesce together. So all of it will come together, and it will form a cavity. So eventually all of this will form a cavity. So now it doesn't look like this anymore. Now you have a layer on the inside, okay, and another layer on the outside, because it's been separated by the cavity, by the coelom, and the coelom has come together and has obliterated the middle part. Okay, but you have an area where the coelom will still persist. Okay, the extra-embryonic mesoderm will still persist. So now in the extra-embryonic mesoderm, you have actually two layers and an area where this extra-embryonic mesoderm has persisted. Okay, and now this is called the outer layer. Okay, so your outer layer of extra-embryonic mesoderm, and on the inside here is the inner layer. Okay, and both this layer is connected by this structure here, the part of the extra-embryonic mesoderm that persisted, and this is called the connecting stalk. Okay, the connecting stalk is eventually where the umbilical cord will develop, right? So the outer layer here is also called the somatic layer. Okay, and the inner layer is also called the splagnic layer. All right. Now, as a recap, okay, so previously you have your embryoblast, okay, so you have your yolk sac there, and then you have your cytotrophoblasts, okay, cytotrophoblasts on the outside. All right, so now I'm just going to zoom in on this part here, okay, and yolk sac will produce a lot of extra-embryonic mesoderm, okay, so extra-embryonic mesoderm, and then eventually you have coelom occurring. So you have coelom in this area here that will give off spaces, and eventually this coelom all will come together through coalesce, and then you have the two layers of extra-embryonic mesoderm, the outer, the inner, and now you have a cavity in between them. Okay, so this cavity here is called the chorionic cavity. Okay, so if you look at this picture, this cavity here on the inside here, that's your chorionic cavity. Chorionic cavity is in between two layers of the extra-embryonic mesoderm, the inner and outer, or the splagnic and somatic. And the only part of the extra-embryonic mesoderm that's not going to have a cavity separating it will be the connecting stalk, which it will eventually become the umbilical cord. Okay, now that we have all these layers, we have produced all these layers, okay, we're going to talk about, if I'm going to take a cross section, or if I'm going to take this here, okay, oops, not there, okay, if I'm going to take a chunk of this, okay, I'm going to cut this chunk, okay, so this chunk here will be going to be, you can see that you're going to have a layer of orange, which is the outer layer of the extra-embryonic mesoderm, or the somatic layer of extra-embryonic mesoderm. And then underneath that, you'll find that I will have the cytotrophoblasts, okay? And then I will also have the syncytiotrophoblasts underneath that, Okay, so the whole 3 layers of this, that's too thick. The whole 3 layers of this, okay, the somatic layer of extra-embryonic mesoderm, the cytotrophoblast, and the syncytiotrophoblasts. This here is known as the chorionic plate. Chorionic plate. Okay, so later on when you're asked, when you see the formation of placenta, okay, you see that part of it will be formed by the chorionic plate. So what is going to be what will you understand from the term chorionic plate is that it's going to be made out of 3 layers, which are your somatic extra-embryonic mesoderm, somatic layer of extra-embryonic mesoderm. You're going to have the cytotrophoblast and you're going to have the syncytiotrophoblasts. Okay, so that is known as chorionic plate. All right, okay for now. Any questions?
Doctor, what was the 3 layer of
You
chorionic
tell.
plate?
Okay, you tell me what's the 3 layer of chorionic plate. You can see here that I've drawn this 3 layer, 1, 2, and 3. So what is the one in orange?
Somatic.
Mr. Nekula. Yes? So you can see the 3 layer here. You don't have a pointer
The
here.
first one
would
is
be-
orange color is somatic layer.
Okay, oops. No wonder. What somatic layer?
It's the orange color, the inner layer of the
Outer layer.
outer layer of the extra
Yeah.
embryonic mesoderm.
Okay. What is the one in black?
The black one is cytotrophoblast.
Yes. And then outside of the cytotrophoblast will always be the
Syncytiotrophoblasts.
yes. So that is what forms the chorionic plate.
Okay. Thank you, doctor.
All right. Okay. Let's see where we are. Any questions? Any other questions?
Doctor?
Yes.
I thought that the primary villus was formed after the chorionic cavity.
It will all of this will occur in tandem with each other, but it actually already formed when even before the chorionic cavity has formed. It will form along with it,
Okay.
but yeah, even before that you have a very, because primary villus is the first main, it's sort of like a scaffolding of what your tertiary villi would be, so you have to form it quite early on before everything else. Okay, all right, now we're going to look at how all of this will play into the uterus. So we're going to implant this structure into the uterus, into this structure here, which is what occurs in normal being. So I'm just gonna draw a very rough uterus here. Okay, right. Okay, so remember you have your perimetrium, you have your myometrium, and you have your endometrium. And in the endometrium layer is where you find the 3 layers, your basal layer, okay, your spongy layer, and your compact layer. And these 2 layers will be the functional layer. So the endometrium will, the product of the embryo, the product of conceptus, will actually embed in these 2 layers here. It's not, sometimes people think of how the embryo gets to the uterus and you think that the embryo is just suspended in the uterine cavity itself. Before that, it doesn't. It will actually embed in the endometrium so that it will receive all the nutrients and the blood supply. Okay, from where you derive all that is from the endometrium itself. So if it's just hanging out here, well, one, basically you can't hang out in a cavity. You can't float there because it's empty. Okay, and also you won't get any nutrient supply to it. So at the beginning, it has to embed in the endometrium for it to be able to survive. Okay, so I'm just going to delete this first because it's going to be quite a big, it's going to be zoom in a little bit so that you can see. Okay, so from this bilaminar disc, okay, remember your bilaminar disc will eventually become trilaminar and eventually it will undergo gastrulation and folding. Okay, so now you have your embryo proper. Okay, very small embryo. Surrounding your embryo, wait, before that, I think it's worth to show you how the folding occurs, or as best as I can show you anyway, because it's just 2D. So if you have your if we cut it this way, okay, we're gonna cut your embryo in that region there. So you can see that at first you have these 3 layers, okay, 3 layers of your ectoderm, mesoderm, and endoderm, and then you have the amniotic cavity, and you have the yolk sac underneath that. What color was yolk sac? Yolk sac was blue also. Okay, you have your yolk sac underneath that. And as this folds, okay, so it will fold that way. Okay, the yolk sac will become smaller and smaller. Okay, so as it folds, you have the 3 layers. Okay, and then you have the small yolk sac. The yolk sac becomes smaller and smaller. But what will happen is that the amniotic cavity will become bigger and bigger. Correct? So eventually all this will have the embryo. Okay. And then you have a little small yolk sac there. Okay. And you have the amniotic cavity. Correct? So all this is when you learn about your embryology with Dr. Reshma, how it folds and everything. Okay, and then surrounding your amniotic cavity, remember you have the 2 layers of your mesoderm. Okay, mesoderm will have to be in orange to make it. Okay, you have the inner layer of your mesoderm, and then you have the outer layer of your mesoderm. Okay, and connecting these 2 layers would be the connecting stalk. Okay, so connecting stalk will connect the somatic layer and the splenic layer. Okay, and outside of this splenic layer, you'll find your cytotrophoblasts. I'm just going to show how it folds and what it will eventually looks like, so that when I draw as it implants into the uterus, you can imagine it better. And outside will be the syncytial trophoblasts. Okay, and don't forget you have your primary villus. Okay, so primary villus will be all around the embryo, and also, of course, you have the lacuna. Okay, your lacuna system. All right, so eventually after folding, what first looks like this, you can see it, right? I didn't, okay. What first looks like this will look like that because of the folding of the embryo. You've now made your amniotic cavity bigger and made your yolk sac smaller. So again, this here is your embryo, all right? This here is your amniotic cavity, all right? That's your inner layer of the extra-embryonic mesoderm, or also called the splenic layer of the extra-embryonic mesoderm. Okay, and then this here would be the outer layer of extra-embryonic mesoderm, or the somatic layer. In between these 2 layers, you find your chorionic cavity, right? Also connecting these 2 layers at one point, okay, at a small space. This is called the connecting stalk. Right. Now outside the somatic layer, you find your cytotrophoblasts, and then you have your syncytial trophoblasts. Okay. Also, you have your primary villi and the lacuna. Okay. All right. Now we're going to implant all this into the uterus. So as we implant all this in the uterus, we're going to look at it in the embryo shape. Okay, so basically we're just going to draw the same thing. You have the amniotic cavity, okay, and then you have the inner layer of your extra-embryonic mesoderm, okay, and then you have the outer layer of your extra-embryonic mesoderm, right, and then connecting it will be your connecting stalk, okay, and then of course you have your cytotrophoblast, and surrounding the cytotrophoblast will be the syncytiotrophoblast. So you have your syncytiotrophoblast surrounding it, okay, and then don't forget your primary villus. Now what I want to do is that primary villus will be everywhere, okay? Primary villus will be all around the embryo, but for the simplicity of this drawing, I'm not going to draw it all around. I'm just going to draw it on one side. But it is going to be present everywhere in the around the embryo. Okay, so now what I'm going to do is I'm going to change the color of the uterus, of the endometrium. Okay, so we're going to do it in green so that you can see. Okay, so now this whole thing will be implanted in the uterus. Okay, so the uterus or the endometrium will have to expand. Okay, so endometrium will have to expand. Now remember, you have three layers of the endometrium: basal, spongy, and compact. Okay, so the embryo is going to implant in here. So underneath the embryo, you still find the basal layer of your uterus. Not the basal layer, but the basal layer will be on the inner part, okay, but on the outer part here, you will still be the functional layer. To draw it nicer. Okay, so if I just extend this one will all be the basal layer. Okay, and this green structure, okay, this green structure here will be the functional layer, which is your compact and spongy layer. All right, now as the embryo is now implanted in the endometrium, in the functional layer of endometrium. Remember the functional layer of endometrium that has is under the influence of the corpus luteum of pregnancy, okay, under the progesterone that is produced by the corpus luteum of pregnancy. The endometrium, the functional layer, is now known as decidua. Okay, so now the embryo is implanted in the decidua. As the embryo is implanted in the decidua, all the decidua will have different names depending on its relation with the embryo. But don't forget also, at the same time, your villi now will change from primary villus to secondary villus. Remember primary villus, okay, it was just a core of cytotrophoblasts, and outside that will be covered by syncytiotrophoblasts. Okay, so you can see here, that's your cytotrophoblastia, and outside there will be, all this will be your syncytiotrophoblasts. So now what's going to happen to your primary villus? Okay, if I just draw this bigger so that you can see. Okay, that's going to be the decidua. Then it's your cytotrophoblast. Okay, and then it's going to be covered by your syncytiotrophoblasts. Okay, that's your primary villus. So now what happens is that the extra-embryonic mesoderm here, the somatic layer, okay, it will proliferate, and it will actually move or invaginate into the cytotrophoblast of the primary villus. Okay, so it's going to happen in all the primary villus. It's going to proliferate. Okay, the mesoderm is going to proliferate and is going to invade or invaginate into the cytotrophoblast of your primary villus. Now, this is what a secondary villus looks like. Okay, so I was just to take this. This is what a secondary villus would look like. So now you have the core will be the extra-embryonic mesoderm, okay, which is going to be produced by the somatic layer, okay, and then outside it will have your cytotrophoblasts, and then on the outer part will be the syncytiotrophoblasts. So this is now known as secondary villus. So core is your extra-embryonic mesoderm, all right, which is going to be covered by cytotrophoblasts, which is going to be covered by the syncytiotrophoblasts. All right, so primary was the cytotrophoblasts and syncytio. Now secondary, you have invagination of the mesoderm, the extra-embryonic mesoderm, underneath the cytotrophoblast. So this is now your secondary villus. And all of these, the changes of the primary to secondary villus will occur all around the embryo. But obviously, I'm not going to draw all around because it's just too much to draw. But it will occur everywhere surrounding the embryo. Okay, so as the implantation occur, the villus will also change from primary to secondary villus. Now with the invagination of the extra-embryonic mesoderm that comes from the somatic layer of your extra-embryonic mesoderm. Okay, so now we're going to look at the different types of decidua that you have here. Okay, so if I were to show you this bit here, all of this, okay, so this part of the decidua, we name it as number 1. Okay, this decidua here, you can see here in green. Okay, all of this here in green. This decidua is in between the product of conceptus and the myometrium. So this decidua here is known as, number 1 is decidua basalis. Okay, in between POC and myometrium. Myometrium or the basal layer of the endometrium. Okay, so that is known as your decidua basalis. Decidua basalis will be this one that is labeled number 1. Now between the product of conceptus, okay, this decidua here, all around here. Okay, so it's between the product of conceptus and the uterine cavity. Okay, this here labeled as number 2 is known as decidua capsularis. Okay, it basically forms kind of like a capsule in between the product of conceptus and the uterine cavity. So it covers the product of conceptus and it keeps it safe from the uterine cavity. So that's your decidua capsularis. Now you have all the other decidua here. Okay, so these are all still your endometrium. Okay, it all has gone through the decidual changes, but it is not near the product of conceptus itself. It's not near the embryo. So the third layer of the decidua, or the third part of the decidua, is called the decidua parietalis. Okay, so this is all the remaining decidua. Okay, again, if you missed it, okay, so if I highlight this area here, this decidua, underneath in between the product of conceptus and the myometrium, okay, that's known as the decidua basalis. Okay, if I highlight this decidua here, this decidua is in between the product of conceptus and the uterine cavity here. This is the decidua capsularis. And then the rest of the decidua that is not near the product of conceptus, this is your decidua parietalis. Okay, so which part of the decidua that will eventually take part in the formation of your placenta is this decidua here, the decidua that is underneath the product conceptus, between the product conceptus and myometrium. So the decidua basalis is the one that would contribute to the formation of the placenta. Knowing this, now you know that the placenta will develop from both the maternal tissue and also the fetal tissue. Okay, so the contribution from the maternal side would be the decidua basalis, which is actually the functional layer of your endometrium underneath here, in between the product conceptus and the myometrium. So you can see that the endometrium actually does contribute to the formation of placenta. All right. Any question? No question. Okay, now we're going to look at back at the embryo, and we see that you have your secondary villi. Okay, secondary villi is going to be again everywhere surrounding the embryo. Okay, but if you can just imagine, right, the embryo is going to grow and grow and grow. Okay, along with it is all your amniotic cavities also going to grow, and as it grows, okay, it's going to obviously it has to grow outwards. Okay, it has to grow outwards. It cannot go inwards because here you have the tough layer of perimetrium and endometrium. Okay, so it cannot burrow deeper inside the myometrium. Okay, all it can do is it can go outwards, and what it does, it will stretch out all your cytotrophoblasts, the syncytiotrophoblasts. So eventually, when that happens, okay, the secondary villi near the in between the embryo and the myometrium, okay, the secondary villi near the decidua basalis is going to persist. Is going to, because it also has more blood supply. Okay, it's going to grow bigger and bigger, but the secondary villi in this region here, okay, because of all the pressure that you get from the growing embryo, and also the diminishing blood supply, because obviously this is further than all your myometrium, okay, all your other decidua here is going to get the primary blood supply. Okay, so all of these secondary villus on this side, okay, on the side of the uh, decidua capsularis is going to degenerate. Okay. So now you're only left with cytotrophoblasts and syncytiotrophoblasts on this side. So all the secondary villi here has degenerated. Okay, so it has stopped. Not only has it stopped growing, it has also regressed. Okay, so now what happens is that in this region here, the chorionic plate near the decidua capsularis will become smooth because it does not have any more of the projection of the villus of the secondary villi. So the decidua underneath the chorionic plate underneath the decidua capsularis will become smooth, no villi, and this chorionic plate in this region, okay, so the chorionic plate in this region here, the chorionic plate in this region here will be smooth, no villi, and you also have a different name. Okay, now you have the different, you have to differentiate the two parts of the chorionic plate. So since it's smooth, okay, it's known as the chorionic levi. Okay, so this is the chorionic plate underneath the decidua capsularis. Okay, so chorionic plate underneath the decidua capsularis is going to not have any villus. The villus will degenerate and it's going to leave the smooth chorionic plate. You call it the chorionic levi. Meanwhile, the chorionic plate that is going to be near the decidua basalis, okay, is going to have the villus, okay, the secondary villus is going to have bigger villus. So the villus will actually grow bigger, more significant. Okay, so you have all this finger-like projection. The chorionic plate will be known as chorionic frondosum. So this would be chorionic plate near the decidua basalis. Right? So remember the decidua basalis contributed to the formation of placenta. Okay, that's the maternal contribution to placenta. Now for the fetal contribution to the placenta is going to be your chorionic frondosum. Okay, so if you see in this picture here, that's your decidua basalis, and this here would be the chorionic frondosum. So these two structures, these two layers, they one from maternal side, which is from the functional layer of the endometrium, and one from the fetal side or the embryo side, which is your chorionic plate the extra-embryonic mesoderm, the outer layer, and then you have your cytotrophoblasts, and then you have your syncytiotrophoblasts. So this will have a lot of secondary villus. It's going to have a lot of finger-like projection. We're going to call it chorionic frondosum. That is going to be the contribution of placenta from the embryo side. Okay, so placenta is going to be made up of two different kinds of cells. Okay, two different kinds of tissue, one from maternal, one from fetal. Okay, so the maternal would be the residua basalis, and the fetal would be the chorionic frondosum. All right, any issues thus far? Okay, you don't have any other problem. Okay, now what we're going to do, is we're going to see further how these structures or this embryo will grow and grow and grow to eventually fill up the whole uterine cavity. Okay, so I will just delete all this numbering, this labeling. Okay, this number 2, number 3, you all know the different types of decidua. So you have decidua parietalis, capsularis, and basalis. Okay, residua basalis again will form the, what do you call that, the placenta from the maternal side. Okay, and the fetus will be formed by the chorionic frondosum. Okay, all right, so if I'm going to remove this bit here for a while. Okay, just for a while, so that you can see what's going to happen. Okay, remember your cytotrophoblasts, your syncytiotrophoblasts, and then you have the extra-embryonic mesoderm. Okay, so now what will happen as the embryo grows? Okay, I guess now it's going to be called fetus. As the fetus grow and grow and grow, okay, the amniotic cavity will also grow. So they will all grow quite rapidly. Okay, the growth will take place quite fast. Now that the fetus is going to grow, the amniotic cavity is also going to be filled with a lot of amniotic fluid. Okay, so eventually, the amniotic cavity is going to grow very big, that it will push the inner layer of the extra-embryonic mesoderm towards the outer layer of extra-embryonic mesoderm. So you have this, so you have this growth of your amniotic cavity, okay, that you will push that's your connecting stop. The inner layer will become bigger and bigger. The amniotic cavity will become bigger and bigger, and you will push the splanchnic towards the somatic. So this here was your splanchnic. Okay, that's your splanchnic. This is your somatic. So you push it nearer towards the somatic. As you push it nearer towards the somatic, okay, the cavity that once was here, this cavity here, your chorionic cavity, will become smaller and smaller and smaller. Okay, and eventually the chorionic cavity will actually disappear. So eventually the amniotic cavity is going to grow so big. Okay, so the amniotic cavity is going to grow so big that you have now obliterated the chorionic cavity. So the inner extra-embryonic mesoderm has now fused with the outer extra-embryonic mesoderm. Okay, and the cavity has now obliterated. Okay, and eventually, as your amniotic cavity grow bigger and bigger, you also actually push the amniotic sac or the amniotic lining to go to be flush with the chorionic, the extra-embryonic mesoderm here. Okay, so all these 3 layers will eventually fuse. These 3 layers will fuse. Okay, so that is the layer. Layer number 1 will be the amniotic sac. Okay, area number 2 would be the inner extra-embryonic mesoderm, and number 3 would be the outer extra-embryonic mesoderm. So all of this will fuse together to form the amniochorionic membrane. Can you see that? Sorry. Okay, amniochorionic membrane. As the amniotic cavity fill up with the growing fetus as well as the amniotic fluid, it will grow so big to eventually push the inner extra-embryonic mesoderm towards the outer embryonic mesoderm and therefore obliterate the chorionic cavity. And eventually, all these 3 layers, the amniotic layer, the inner extra-embryonic membrane, extra-embryonic mesoderm, and the outer extra-embryonic mesoderm will all be fused together, and that forms the amniochorionic membrane. So eventually, this amniochorionic membrane is the one that will form your amniotic, what usually people call the amniotic sac. Okay, but the proper term is the amniochorionic membrane. That is the one that will burst when at the start of labor. Okay. Okay, now as it grows and grows, so now it has formed this amniochorionic membrane. It will also grow as big as the uterine cavity, and it will all fill up the uterine cavity. Okay, so now that you have the fetus and the amniotic cavity that will grow bigger and bigger, so it will push outwards. Okay, it will push outwards to eventually it will grow to occupy the whole of the uterine cavity. Now, as it grows bigger and bigger, okay, as it goes, as the fetus and the amniotic sac grows bigger and bigger, we will actually degenerate the decidua capsularis. Okay, because the decidua capsularis will be so stretched that it will have to degenerate. Okay, so it will eventually degenerate, and the cytotrophoblasts and the cytotrophoblasts will also eventually degenerate as well. So you will only left with the chorionic frondosum, okay, the chorionic frondosum here, and the decidua basalis. Eventually, all of the structures in this region, okay, as the embryo grows, as the fetus grow, will degenerate. So the cytotrophoblasts, the cytotrophoblasts all will degenerate along with the decidua capsularis. So eventually, all of this will look like this. Okay, so we're going to draw what's going to happen when the fetus will take up the whole of uterine cavity. So your decidua basalis is still there. Okay, maybe we can draw the decidua basalis bigger, okay, to show that it's going to persist. Okay, and then you have the, okay, I'm going to draw the fetus so big. Okay, it's going to be like that. And then you have the amniotic cavity. Okay, and also don't forget you also have the chorionic part, okay, which was the extra embryonic mesoderm that has now fused together both the inner and outer layer, and then you have the connecting stalk. So connecting stalk is still there along with the chorionic part here. So in this region, don't forget you still have your your chorionic frondosum. Okay. So along with the cytotrophoblasts, you have your secondary villus. Okay. I should probably draw the decidua further up. Okay. The decidua is still there, but obviously it's going to be on the outside. Okay. And then you have your lacuna here. Okay. And in your secondary villus, don't forget your extra-embryonic mesoderm core. Okay. So all of that is going to still be persisting because that's going to form the placenta. Okay. And then okay, what do I have? Is there something on the chat? Sorry. Oh, form. Okay. So eventually it will grow so big that the cytotrophoblasts, cytotrophoblasts in the decidua basalis, the decidua capsularis is going to degenerate. So now what will happen is this layer, remember what it's called? It's called the Amniochorionic membrane, is going to come in contact with what was this one here originally? That is your decidua parietalis. So the amniochorionic membrane is going to, the separation was the cytotrophoblasts, in situ trophoblasts, and the decidua capsularis, which is now all gone. So now the amniochorionic membrane is actually going to come into contact with the decidua parietalis. And then eventually it will grow bigger and bigger, and the uterus has to also grow bigger and bigger. So at first, this is how the product of conceptus will take the whole, or will occupy the whole of the uterine cavity, and then the uterine cavity eventually will have to grow as well in size to accommodate for the fetus and the growing amniotic sac as well. Okay, so this here is your amniotic cavity. This here is your amniochorionic membrane. Okay, that's your decidua parietalis that will come in contact with. Okay, that's your connecting stalk. Okay, and this here would be the placenta. All of this will be your placenta, which is going to be formed by this here would be the chorionic frondosum. Okay, and this here would be the decidua basalis. Okay, no questions? If no questions, we're going to be focusing on the placenta itself. So we're going to take this and we're going to draw it bigger, and we're going to see what it looks like and how the exchange of blood will occur. Okay, all right. If we're going to take this structure here, okay, if we're going to take this structure here and we're going to dissect it, so we can see that the placenta is going to be formed by the decidua basalis, by your chorionic frondosum, and all the layers that it is made up of. Okay, so now here, let's draw the decidua basalis. Okay, bigger. Okay. So on the maternal side, we have the decidua basalis that will form the maternal side, okay, or the maternal contribution to the placenta. And from the fetus side, you have the cytotrophoblasts. Okay, so you have your secondary, bigger problem. You have your secondary villi. Okay, so secondary villi is going to be made up of your cytotrophoblasts. I'm just going to draw maybe about 2 secondary villi to show you. Okay, so another secondary villi there. Okay, and all your secondary villi came from the cytotrophoblasts. So you have the cytotrophoblast layer. Okay, so underneath the cytotrophoblast, you're going to have the chorioamniotic membrane. So you have the one in orange. Okay, so that's your part of the extra-embryonic mesoderm, and then you're going to have your amniotic layer. Okay, so this two is your amniochorionic membrane. Okay, so it's made up of the extra-embryonic mesoderm and the amniotic layer. Okay, amniotic sac. So in between because it's secondary villus, so you have to have the core of the extra-embryonic mesoderm. Okay, so this core, remember, comes from originally from the outer layer of your extra-embryonic mesoderm. Okay, the somatic layer. All right, and then of course you have the lacuna. Okay, so some lacuna is going to be connected, okay, with each other. Okay, so you have the lacuna in between the villus. Okay, so this is your secondary villus, right? This is what the zoom section of the whole region is going to look like. So that's your decidua basalis. Okay, that's your amniochorionic membrane. Okay, this here would be the secondary villus. Okay, that's your secondary villus there, and that's your lacuna. All right. Now, what's going to happen is that from the secondary villus, you're going to have the secondary villus going to change to tertiary villus. Now, what's going to happen in the tertiary villus is that this extra-embryonic mesoderm, okay, the middle part here is going to differentiate because mesoderm in the fetus itself as well, okay, mesoderm is going to contribute to the formation of blood vessels of the cardiovascular system. So for the extra-embryonic mesoderm, it's also going to differentiate to become blood vessels. So now you have this differentiation, okay, of the structure here. Okay. So it's still going to have that capsule of extra-embryonic mesoderm, but inside here you're going to have blood vessel. Okay. So inside the tertiary villus, you find that you have a blood vessel inside, okay, at the core, and then you have a layer of extra-embryonic mesoderm, another layer of that's going to be covered by cytotrophoblasts, and then also by the syncytiotrophoblasts. So all here in this region here is actually your syncytiotrophoblasts. If I were to give it another color, okay, all here would be your syncytiotrophoblasts, okay? But obviously you don't have any layers to it, you don't have any structure to it because it's just a mass of your cytoplasm. So now tertiary villus is going to be made up of the core will be the blood vessel, okay, and then you have blood vessel covering that will be the extra-embryonic mesoderm, and then what's going to cover all of that will be the cytotrophoblasts, and then eventually it's all going to be covered by your syncytiotrophoblasts. Okay, so this is what tertiary villus is going to be made up of, the architecture of the tertiary villus. So if you just these two, this is your primary villus. Okay, but if you do all these three, is your secondary villus. Okay, but if you have all these four layers, then that's your tertiary villus. Okay, so primary is the cytotrophoblast and syncytiotrophoblasts. Secondary will be the extra-embryonic mesoderm with the cytotrophoblast and syncytiotrophoblasts. And lastly will be tertiary, where you have blood vessel. Okay, the extra-embryonic mesoderm has now differentiated to become blood vessel. So that will be covered by extra-embryonic mesoderm, cytotrophoblast, and syncytiotrophoblasts. So this is how the villus will progress, okay, from just a simple layer of cell, a simple structure that's made out of cell and the syncytiotrophoblasts, you're going to have eventually blood vessel inside it as well. Okay, all right, so that is how the tertiary villus will come about. Okay, so eventually as the tertiary villus will be produced, okay, you have the cytotrophoblasts will further proliferate to become locked to the decidua basalis. So the cytotrophoblasts, okay, forgot, outer here will be another layer of your, it will, the cytotrophoblasts will proliferate to upwards toward the decidua basalis, and then it will also give off a layer of cytotrophoblasts to form a little shell around everything, around the what do you call it, the embryo part. Okay, so it will form this shell, and all of these spaces, the lacuna, will eventually all be will coalesce with one each other to form the intervillus spaces. So the lacuna will become so big that eventually it will form all of this here on the outside here will be your lacuna lacuna spaces will eventually be known as intervillus spaces. Okay, the lacuna system will become bigger, okay, and it will combine with other lacuna that eventually it will just become a space between the intervillus, between all the villus, so intervillus spaces. So the syncytiotrophoblasts has been pushed to be very near the cytotrophoblasts. Okay, so the syncytiotrophoblasts is going to be a smaller layer. Okay, but you have mostly will be the intervillus spaces will take over. Okay, so now you have cytotrophoblasts here. Okay, syncytiotrophoblasts will be very small. Okay, it will just be located here. Okay, because it's being pushed away by the intervillus space, because the lacuna has grown so big that now most of the space in between the villus will not anymore be your cytotrophoblast. There will not be your syncytiotrophoblasts, but will be your lacuna spaces, which is going to be renamed to intervillus spaces. Okay, but the villus is still going to be anchored to the desua abyssalis, because you have the proliferation of all the cells that will anchor it to the desua abyssalis, and then it will form this outer shell outside the just deep to the desua abyssalis. So now you have this villus here is called the anchoring villus. Okay, because the tertiary villus that anchors the whole structure to the desua abyssalis is called the anchoring villus, and this proliferation of cytotrophoblasts is going to call the outer trophoblastic shell. So all of this is going to be the intervillus spaces. Okay, so intervillus spaces, you can imagine, is going to be made up, is going to be filled by the maternal blood. All right, so now how does that happen is that you have so previously also you already have the spiral arteries that will be eroded. Okay, so spiral arteries that will be eroded from the maternal side. Okay, and it will open up into your intervillus spaces. So all the blood from the mother, the maternal blood, will go into the intervillus spaces, and you also erode the veins as well. Okay, so all the blood that goes inside will also go back outside. Okay, because arterial system is high pressure, so it will push all the blood inside, and once it goes inside, it will bounce back. It will hit the chorionic plate here. It will hit the chorionic plate here, and it has to bounce back upwards. As it bounces back upwards, the veins, the spiral veins, will catch all the blood to return back into the mother's venous system. Okay, any questions up to that? Okay, so far?
Doctor,
Yes.
once the intervillus spaces is formed, then what happens to the syncytiotrophoblasts?
The syncytiotrophoblasts is going to be pushed aside by the intervillus spaces, because the intervillus spaces is going to be filled up with blood, right? So the intervillus spaces will be very, very sort of like quite high pressure, because you're going to get blood from the arterial system. So what happens is that the syncytiotrophoblasts will be pushed towards the cytotrophoblasts. So all of the syncytiotrophoblasts that was all here just now, okay? So because the intervillus spaces is expanding, so now the syncytiotrophoblasts will just form a small layer around the cytotrophoblasts. Will still be there, but it'll be a smaller layer. It will be a much smaller layer, because most of the spaces will be filled by your intervillus, by the blood that is going to be occupied by in the intervillus spaces. Okay.
Okay, doctor. Thank you, doctor.
Okay. So now we're going to see both the maternal and fetal circulation in the placenta. So this is almost sort of like the final part. Okay, but we're going to put in an embryo, and we're going to see what it really looks like. Okay, so remember you have your decidual basalis. Okay, so the part of the decidual basalis that that forms the embryo, sorry, the placenta proper, is known as the decidual plate, and the part of the chorionic frondosum that forms the placenta proper is going to be known as the chorionic plate. Okay, so here is your decidual plate, which was from the decidual basalis, if you can still remember. Okay, and then you also have the chorionic plate. Okay, so chorionic plate is going to be from the um, embryo. Okay, that's going to be um, part of the amniochorionic membrane. Okay, but I'm just going to draw the chorionic part, the chorionic plate, so that it looks cleaner. Okay, and then don't forget your connecting stalk. So connecting stalk is going to connect the whole thing, maybe a bit wider. Okay, it's going to connect the whole thing to the, and what will be here will be your, okay, very happy embryo. All right, so the embryo is going to also have, remember, it's going to have its mesodermal layer, and the mesodermal layer will also differentiate into the cardiovascular system. So you have your heart and you have your blood vessel that will bring the oxygen and nutrients to all the cells in the embryo, and eventually it will also form a blood vessel that will go towards the connecting stalk. Okay, so this blood vessel, you have 2 umbilical arteries and 1 umbilical vein. Okay, so all of this mesoderm here will eventually also differentiate to become blood vessels. So inside here you have blood vessels. Okay, mesoderm, and most of the function of the extra-embryonic mesoderm is to produce or to differentiate into blood vessels so that you can connect the fetal circulation to the maternal circulation. Okay, so here I'm going to draw 2 what do you call that, villus. Okay, you have your layer of villus. Okay, and another villus here. All right, so that's going to be your mesodermal layer. Okay, so inside your mesoderm, remember your tertiary villus is going to have your mesodermal layer, and then you're going to have the blood vessel inside. Okay, so blood vessel, mesoderm. Okay, so that's the blood vessel there. And then outside of your mesoderm is going to be the cytotrophoblasts. Okay, don't forget your cytotrophoblasts. It's going to be made up of cells. Okay, cytotrophoblasts here. Maybe if we can move the decidua higher up, maybe better. Okay, so that's going to be your cytotrophoblasts here. We're going to cover the mesoderm. Okay, and don't forget that you have the cytotrophoblast that is going to go anchor the villus to the decidual basalis, and then it will form the outer trophoblastic shell. Okay, so your outer trophoblastic shell everywhere. All right, and then what's going to be covering the cytotrophoblast is going to be a layer of your syncytiotrophoblasts. Maybe that's too thick. Okay, it's going to be a layer of your syncytio. It is too thick. Trophoblasts. Okay, but of course the syncytiotrophoblasts is going to be small because it's going to be covered by, it's going to be pushed aside by the intervillous spaces. Okay, so this is how a mature placenta would look like. Okay, in this region here, you'll find the intervillous spaces. So the spaces here will be the same thing. Yeah, I'm just going to draw it more simpler on the side. So you have the opening of the spiral artery, okay, from the maternal side, and then you have the opening of the spinal vein as well. Okay, so blood is going to come in through the artery, okay, it's going to go down, and as it hits the bottom, the chorionic plate, it will be reflected up. As it's reflected up, it will actually go in between all these villus spaces here. Okay, so the blood is going to go all of it and eventually return back into the spiral vein. Okay, but before we go all that, before we get ahead ourselves, the blood vessel here, the fetal, the extra-embryonic mesoderm, remember it will differentiate into blood vessels. Okay, and these vessels in your villus will be connected to the blood vessel of your chorionic plate. Okay, so all these extra-embryonic mesoderm will also differentiate into blood vessels. Okay, and then the blood vessels of your chorionic plate will also be connected to blood vessels in the connecting stalk. Okay, so connecting stalk here will eventually become the umbilical cord. So this actually is already known as umbilical cord. Okay, umbilical cord, the blood vessels that will differentiate in it will be two umbilical artery and one umbilical vein. All right, so the umbilical artery, you have two umbilical artery. So inside here, you will actually find two umbilical artery. Okay, and the umbilical artery is going to be connected to the vessels of the baby. Okay, the iliac vessels of the fetus. Right, so the iliac vessels of the fetus is going to be connected to the umbilical artery, and that's going to bring the blood away from the baby. So blood from the baby, okay, deoxygenated blood will come out through the iliac vessels or iliac artery of the baby into the umbilical artery, and then the umbilical artery is going to, I'm just going to draw, just going to draw the deoxygenated blood, so we have blue. Right, so from the baby, the deoxygenated blood go into the iliac artery, into the umbilical artery, okay, and then from the umbilical artery into the chorionic artery, okay, from the chorionic artery into the villus artery. And here it will be coming into contact, not really coming into contact, but it will be very near to the maternal blood. So then it will exchange gases, nutrients, metabolites, whatever that needs to exchange between the fetus and the mother. Okay, so as I
Slow
mentioned,
diffusion, right, doctor?
yes, to slow diffusion, sure. But other molecules, you have different kinds of what do you call that, processes. We'll be looking at it when we talk about the function of the placenta. Okay, so gases, yes, through simple diffusion. All right, for the maternal blood, okay, it will come from the spiral artery. It will, because it's very high pressure system, it will go all the way down straight, and then it will it will bounce onto the floor of the intervillous spaces, and then it will go, as it comes back, it becomes slower, and it will go through or go in between all the villus spaces here, and eventually it will go back up, back to drain into the spiral vein. Okay, and you can see in this region here, okay, so this region here where the fetal blood goes in here, it will also go towards this area here. Okay, so it'll be very, very closely related to the blood of the mother, although it does not touch each other, it does not come into contact, it does not mix together. Okay, just remember that's a very important concept, that the fetal blood and the maternal blood does not mix together. Okay, you have this barrier that will separate these two these two blood circulation from each other, because this is a different individuals, different genetic makeup. You cannot have the blood mixing together. If you have that, then you have you can have a very bad reaction to it, and you can cause death to both fetus or mother. Okay, so the placental barrier is very important to ensure that the blood does not mix together. Right, and eventually all the blood will then, after the blood from the fetus Okay, after it has gone into the what do you call that? The villus spaces, then it will return back. Okay, it will return back through the vein of your villus vein back into the chorionic vein, and eventually it will drain back into the umbilical vein, and this will go back into the fetal circulation. Okay, so from the fetus, deoxygenated blood will be going through the umbilical artery into the chorionic artery, into the villus artery. Okay, and from there it will exchange whatever molecules or gas with the maternal blood. Okay, and then it will drain back into the villus vein, into the chorionic vein, into the umbilical vein, and back into the fetus. Okay, so that's the fetal circulation, the blood that will come from the fetus into the placenta back to the fetus. From the maternal side, it will be from the spiral artery, okay, into the intervillus spaces, back into the spiral vein. So this spiral artery and spiral vein are all located in the endometrium lah. So that's how the maternal circulation will take place for the placenta itself. So for the mother, it will go into the intervillus spaces. For the baby or for the fetus, it will go into the villus only. It does not mix together. Okay? Any questions so far?
Doctor,
Okay.
deoxygenated blood flows through the vein for the fetus part.
For the fetus, it's the other way around. Okay,
Artery.
umbilical artery, will bring deoxygenated blood because you bring it away from the fetus towards the
Okay.
maternal blood. Okay, but the
Okay. Thank you,
venous
doctor.
system will return oxygenated blood.
Oxygenated blood. Okay, thank you, doctor.
Yeah, because the baby lungs is not working, so it has to depend on the mother for oxygen and other kinds of nutrients as well, because other structures are also still developing, your kidneys. So all of the metabolism or the filtration or the what do you call that? You're trying to take out all the metabolites, the harmful metabolites, okay, the products or the waste materials. It has to go through the mother, not the baby itself, because everything is still growing inside there, has not yet able to do all that processes. Okay.
Doctor,
Yes.
I have a question. What if twins? Is it the same thing?
What is what?
Twins or twins?
What do you mean by twins?
I mean, for the twins, is it the blood? The blood work is it the same thing, the same process?
Sure. Yes. Or would it be different? Okay, because it can't depend on each other. It has to depend on the mother as well. But it depends on the type of twins. Because certain twins they share a single placenta. As other twins, they have their own placenta. So if it's their own placenta, then you have the same kind of formation. It's just 2 times 2. Okay. But of course, there are certain twins will have fused placentas, so depending on the kind of twins that you have. Okay, whether it's those with separate placenta and chorion, or whether you have a twin with fused placenta and chorion. But this is just, the formation of placenta that whether it's separate placenta or not, you have to take place as well.
Okay, thank you, doctor.
Okay. All right. Where were we? Okay. Now that you know that the blood does not mix together, okay, so you have the placenta barrier that will keep the blood of the fetus away from the blood of the mother. Okay, now we have to look at the placenta barrier, okay, and the layers that that you have. Okay, so if I were to draw here, okay, in this region here. If I were to draw that is a vessel, okay, you can see, can, okay, so that vessel there, okay, and now what we're going to do is we're going to cut this bit here, okay. Right, we're going to cut this bit here. We're going to zoom into it. Okay, so you have the vessel, you have the villus, and then you have the intervillus spaces. Right, so we're going to draw it over here. Now you have a vessel that would be the fetal vessel. Okay, the villus artery. Okay, and the villus artery, all vessels in the body, okay, is going to be lined by endothelium. Okay, a special type of epithelium where we call it specifically endothelium because it's going to be lining vessels. But here we're going to focus on the smallest of vessels in the villus. We're going to focus on the capillary. So capillary will have one layer of cell, a single layer of cell called the endothelium. Okay, so you have the fetal blood flowing into the villus capillary. Okay, so surrounding the villus capillary would be the, what do you call this? The extra-embryonic mesoderm. Okay, so the extra-embryonic mesoderm is going to be surrounding the villus capillary, and then the other layer. So we're just gonna look at this area here. So you have the purple, and then you have the orange and black and yellow. Okay, so purple, orange. Now black would be your cytotrophoblasts. Okay, so cytotrophoblasts will be surrounding the villus as well. And then surrounding the villus, surrounding the cytotrophoblasts will be the syncytiotrophoblasts. Okay, so that's your syncytiotrophoblasts. So this here is your the structure of your tertiary villus. Okay, the structure of tertiary villus, and remember, what's surrounding all the villus would be the intervillus spaces. So intervillus spaces will be filled with maternal blood. So all this here is your maternal blood filling the intervillus spaces. All right. So now we're going to see what makes up the barrier. So the barrier is going to be this structure here. Too large. Okay. All this structure here is your placenta barrier. So what are the layers of the placenta barrier? Number one, the first layer is your endothelial cell. Okay, endothelium. The second here, okay, that's number two. That's the extra embryonic mesoderm. Okay, and the third layer here will be this one here, number three. Can't see it because, okay, number three is the cytotrophoblast. Okay, and number four here is the one in yellow. That's your syncytiotrophoblasts. Okay, so if I were to ask you what makes up the layers of the placenta barrier, or what makes up the placenta barrier, then you can answer that there will be four layers to the placenta barrier. It's made up of endothelium, extra-embryonic mesoderm, cytotrophoblast, and syncytiotrophoblasts. Okay, so these are the four layers that ensures the blood from the fetus does not mix with the blood from the mother. Okay, so this is all a very good system to ensure that everything is kept in its place and you don't have any intermixing of blood. But eventually, as the fetus grow, okay, the fetus grow and grow and grow. Now it doesn't have it needs a lot of blood supply. It needs a lot of blood supply because it needs a lot of oxygen, it needs a lot of nutrients. Okay, if the layers were to persist like this, the baby cannot grow fast enough. It cannot grow optimally because it's not receiving enough nutrients, enough oxygen. So you have what is known as IUGR, the intrauterine growth retardation. So what happens is that the body knows that the fetus, as it grows after 20 weeks, it needs to grow in a very rapid manner. So what eventually disappears is that layer number 2 and layer number 3 actually disappears. So after 20 weeks, okay, I'm just gonna separate this between after 20 weeks and before 20 weeks. So this is before, this is before 20 weeks. After 20 weeks, layer number 2 and layer number 3 disappear. So the cytotrophoblast, sorry, the extra-embryonic mesoderm and the cytotrophoblast is going to disappear. After 20 weeks, these two layers is going to disappear. Okay, so now the syncytial trophoblast is going to be closely related to the endothelium. Okay, so all of this here will still be filled with your maternal blood. So after 20 weeks, the placenta barrier is only going to be made up of two structures. Okay, so after 20 weeks, only the endothelium, okay, and the syncytium. Okay, before 20 weeks, you're going to have 4 layers. After 20 weeks, this is going to be the endothelium and the syncytial trophoblast. This is to ensure that all the oxygens and nutrients will go into the fetal blood faster to ensure that the fetus can grow optimally as quickly as it needs to. Okay, so that's your placenta barrier for you. Okay? So eventually, the cytotrophoblast and the, what do you call that, extra-embryonic mesoderm will disappear. Okay, so all of this, the one in orange, will disappear from the villus. Okay, and you only have the endothelium as well as the syncytial trophoblast covering the villus. Right? Don't forget that you still have the anchory villi. You have a cytotrophoblast there. But in between the intervillus spaces and the villus, you don't have any more cytotrophoblast and mesoderm. All right, is that okay? Right, now another thing that happens as well, it doesn't happen after 20 weeks, it happens quite early on as well, is that the decidua basalis, so you can still remember your decidua basalis here, the decidual plate here from your decidua basalis, what it does, it will give off septum. So it will give off septum, okay, that will go to the bottom of the chorionic frondosum, okay, but it doesn't go all the way. It doesn't combine, or it doesn't fuse here. Okay, it leaves spaces. Okay, so give off this septum in a few places here. Okay, so the decidua basalis will go down there, come back up. Okay, it gives off this is called a septum. Okay, septum doesn't go all the way to the chorionic plate. It just give off, it divides the room, but it doesn't divide all the way down. Okay, it's sort of like if you have like shower curtain. Okay, so the shower curtain will just be hanging from the top, okay, from the ceiling, I guess, from the decidua basalis, but it doesn't reach the floor. So this gives off septum that would separate the placenta into a few cotyledons. So if you were to look at the placenta, okay, at the full term placenta, you'll find that it has these cotyledons because of the presence of septum from the from the decidua basalis. Okay, I guess the septum is to ensure that when you have organization to a big space, it ensures that the blood that goes in, it helps to maintain the pressure in the system in the intervillus spaces. So it's to ensure that the blood that goes in will be able to rush quickly. Okay, the arterial blood, a high pressure system, will be able to rush quickly to hit the floor. And as it hits the floor, it needs to be able to come back slowly. So it needs to maintain this kind of pressure in intervillus spaces to ensure that the villus will all be bathed in your maternal blood. Okay, because the maternal blood needs to come really, really near to the the villus, okay, to ensure that it will be able to give off your oxygen and nutrients and take away the carbon dioxide and metabolic waste. Okay, and I think that's all for the drawing part. Now if we were to, I'll just show you a bit on the wait, let me just, I have all of this in PowerPoint form, but I thought if we were to look through it, it'll be better. Okay, if we were to draw through the whole process, it'll be better since it will give us a nicer. Oops, not this one. It's not showing the. Not showing my PowerPoint. Can you see the PowerPoint?
No, doctor.
Okay, wait. Now. Do you see the PowerPoint?
Yes, doctor. Thank you.
Okay, so in full-term placenta, you can see that this here would be what a full-term placenta looks like. Okay, so this top part here, okay, it's a sort of like a flat, it's not a full dome. It's like a dome, but it's a flattened-ish kind of dome. So the top part here is where it will be attached into your the uterus. Okay, so this is where the decidua basalis is. So this will be towards the maternal side. Underneath here would be the where the fetal side is. Okay, so the full term placenta, you can see the cotyledon. So this is one cotyledon, another cotyledon. This is caused by the septation that your decidua basalis will form. Okay, the septa that you have. Okay, the fetal side will be flat, all right, and you can see the chorionic plate. Okay, you can see the umbilical cord attached to it. Okay, and that's your amnion. Okay, that's going to be part of your amniotic sac. Okay, so the placenta will be discoid shape. Okay, about 500 to 600 grams, and it will be automatically torn from the uterine wall about 30 minutes after the birth of the child. Okay, so on the maternal side, you have the bulging cotyledons. On the fetal side, it'll be a smooth surface covered by your chorionic plate. Okay, and you can see the chorionic vessels. Okay, remember chorionic vessels that will give off, that will connect to the villus vessels. Okay, so these are your chorionic vessels that you can see. And then you have the umbilical cord. So umbilical cord will usually be eccentric, okay, and occasionally marginal. So eccentric usually will be quite in the middle. Sometimes it will be at the margin as well. Okay, so this is what a full-term placenta would look like. And whenever you have a patient who gives birth, okay, who's in labor, after the third stage of labor, the third stage of labor means the delivery of the placenta. After the placenta has been delivered, you always have to ensure to look at the placenta to see that it's all intact, that it's all complete. Okay, if you have any jagged edges, okay, jagged edges is mostly in the decidua basalis, because this is the part that's attached to the uterus itself. Okay, then you have to ensure that there's no if there's a jagged edges, if there's jagged edges, then it actually signifies that the placenta might have torn, okay, and not torn in a complete way, but if you have some of the placenta actually retained in the uterine cavity. So you have to always ensure that you check the placenta, make sure it looks nice, make sure everything is perfect, it's complete. If not, you have to ensure that there's no retained placenta in the uterus. Because if there's retained placenta in the uterus, then patient can go into postpartum hemorrhage. So the uterus cannot contract properly because there's still some tissues left in there, and you have to evacuate the retained placenta. All right, anyway, functions of the placenta. So these are all the functions. Obviously, number one is to exchange metabolites and gaseous products. Remember, maternal and fetal blood do not come in contact. So the fetal blood cannot go all the way to the maternal lungs to get the oxygen and to give off carbon dioxide. So instead, they have to go through the placenta so for all this to happen. So for nutrients, for electrolytes and vitamins, as well as for gas transport itself. So you can read the specifics of it. Okay, and also not to forget transmission of maternal antibodies, because fetus, they cannot produce their own antibodies yet. So you gain passive immunity. Passive immunity is when you are given antibody. If you build your own antibody, you call it active immunity. So fetus, it cannot build its own antibody yet. It's not sensitized to anything yet. So it can only receive passive immunity from the transfer of IgG from the mother. Okay, so maternal IgG will be given to the fetus to has some kind of immunity, some kind of immune system towards various infectious diseases. Okay, when they're newborn, they can produce their own IgG, but it's not going to be as optimal as adult production of IgG. So adult levels of immunoglobulin will only be attained after 3 years, okay, at around 2 to 3 years usually. So in between that, obviously you don't have any more placenta, you don't have any more umbilical cord, okay, after you're born. So in between that, you get a lot of antibodies from breastfeeding. Okay, so in newborn you can produce your own antibody, but it's not going to be strong enough. Okay, it's going to last, the passive immunity that is given through the umbilical cord is going to last about 6 months. So after 6 months, you can build better antibodies, but you get better supply of antibodies when the mother breastfeeds the child. Okay. Other than that, functions of placenta is to produce hormones. Remember, your Cytotrophoblastia helps to synthesize HCG, so human chorionic gonadotropin, which maintains a corpus luteum. Change it to corpus luteum of pregnancy to ensure that the corpus luteum will produce progesterone to maintain the decidua in the uterus. Okay, after the at the end of the 4th month, okay, so when the corpus luteum cannot produce enough estrogen itself, then the placenta will take over to produce the progesterone to ensure that the pregnancy is maintained. So first, 10 to 12 days will be from the corpus luteum producing progesterone, and then between 12 days to 4 months, it will be by the corpus luteum of pregnancy, and then after that, the placenta takes over to maintain or to produce its own progesterone to maintain the pregnancy. All right. So the first between after the 12 weeks, okay. Remember, your syncytial trophoblast will produce HCG, and this HCG is also what is detected by all your urine pregnancy tests. Okay, your UPTs will mostly detect HCG to signify that the mother is actually pregnant. Okay, the female is in the early stages of gestation. So if I were to ask you what hormone is detected in a urine pregnancy test, then it will be a human chorionic gonadotropin. And if I ask you what produces that, you can answer the syncytial trophoblast. Okay. Other than that, the placenta also produces growth-like hormone, the somatomamotropin. Okay. So this, the somatomamotropin actually it is not exactly a growth hormone, but it acts like it in a way that it will give priority of glucose, okay, the maternal glucose to the what do you call that, to the fetus. Okay, so this can make the mother diabetogenic. Okay, other than that, somatomamotropin also promotes breast development for milk production. Okay, so somatomamotropin, the mammo part means your the mammary glands, so it helps to promotes breast development in the mother for milk production. Okay, so that is a photograph of the fetus and the placenta. You can see that here would be the cotyledons, the maternal side. Okay, it's all very so you can see a lot of bulges to it. Okay, let's just the umbilical cord. We've talked about it actually. Okay, so you remember you have your two umbilical arteries and one umbilical vein in the umbilical cord. Okay, so umbilical cord is about 50 to 60 centimeters long at birth. So at the 38 to 40 weeks of gestation, it will be quite long. And it's tortuous. Okay, so it's the baby inside, the fetus inside moves a lot. So you need to have quite a long umbilical cord to ensure that it is it receives blood supply all the time. But because the umbilical cord is also long, it can cause knots. Okay, it can cause the umbilical cord to be entangled in the neck. Okay, and usually these issues will not be problematic. Okay, especially if it's entangled around the neck, because the fetus is always encircled in amniotic fluid, so the entanglement won't be tight around the neck. But if in the process of giving birth, when the amniotic fluid will all gush out, you don't have that support anymore, then cord round neck is going to be quite problematic in delivery. Okay, and sometimes a very long cord can also cause, instead of false knot, it can actually cause true knots. So what happens is that the umbilical cord will knot around itself, and this, when it becomes a tight knot, then it can cut off blood supply to the fetus, and it can cause intrauterine death. Okay, a short cord will cause difficulty when you pull the placenta from the attachment to the uterus. Okay, so when you're giving birth to the placenta in the third stage of delivery, you have to deliver the placenta. You actually have to pull the cord. We call it a control cord traction. So you pull the cord, but you don't pull it, you don't tug at it. You slowly, gently coax the cord, coax the placenta to come out by pulling the cord slowly. Okay, so if it's a short cord, then you might have difficulty to pull the placenta from the uterus. Okay, other than that, you can also have amniotic bends. That means when you have tears in the amnion, you have the amniotic bends that can encircle parts of the fetus, and this can also result in amputation. So sometimes amniotic bends can encircle the fingers or the limbs, and because the limbs are small and they're very fragile still, so this amniotic bends that encircle this part of the fetus can actually cause amputation. All right. Okay. Now let's see what are the congenital anomalies of the placenta that you can have. So these are the abnormalities in shape. Okay. Remember, placenta is one discoid. Okay, one disc. Sometimes you have bidiscoid placenta. So you have two discs of placenta instead of one big one. You have two smaller ones. And sometimes the placenta can have lobes, okay? So it doesn't look like a nice round shape. It has this lobulated appearance to it. And you have a placenta membranous where the placenta is thin and diffuse, okay? You don't have a thick kind of fleshy placenta to it. So placenta membranous is slightly problematic because the placenta is very, very thin. So if it's a thin, then it can actually easily rupture in pregnancy. Other than that, you have placenta circumvallate, where the peripheral edge of the placenta will be covered by circular fold of decidua. Okay, so the side of the placenta here, instead of the decidua being at the sides nicely, you can have the decidua covering it. Okay, placenta secunturate is when you have an accessory lobe. Okay, or you have a fenestrated placenta where you have a hole in the placenta. Okay, so it looks fenestrated. Okay, this is an accessory lobe. Okay, that's twin pregnancy. So there's one placenta here and another placenta here. That's one umbilical cord, another umbilical cord, and this is the accessory lobe to the placenta. Okay, another accessory lobe there, you can see. Okay, And when you have an accessory lobe, what can happen is that because this vessel here is quite exposed, you can have a bleeding during delivery, and if it's a major bleed, then it's quite a big problem. This here is a circumvallate placenta. Okay, you see that there. And then apart from the difference in the abnormalities in shape, it can also be abnormalities in position. Okay, so when you have the placenta that embeds itself in near the cervix, you call it the placenta previa. So placenta previa, a normal placenta, it's on the upper segment of the uterus. But sometimes the placenta can be in the lower segment. Okay, so it can be part of it in the lower segment, the whole of it in the lower segment, or it can actually even close the internal os. Okay, this is your cervix. That's your internal os. Okay, this is how the baby should come out. Down here below here will be the vagina. Okay, sometimes the placenta can cover the internal os, and when it covers fully, it's very difficult for the baby to be delivered. Okay, because the exit for the baby, okay, the birth canal is covered. So in terms of when you have placenta previa, in the most the worst form of the placenta previa will cover the internal os. So if you have the worst form of placenta previa, then usually the baby needs to be delivered via cesarean section. So this can be diagnosed during antenatal follow-up, okay, antenatal screening. All right, so amniotic fluid. So amniotic fluid is the clear watery fluid that is being produced by the amniotic cells. Okay, it's also going to be, it's produced partly by amniotic cells, but it's derived from maternal blood. Okay, so whatever in the, it's obviously going to be the filtered version of it. Okay, it's not going to be, you're not going to find any blood cells in there. It's just going to be the fluid that's filtered is going to is going to produce the amniotic fluid. So the amniotic cavity will be full of this amniotic fluid. Okay, and after 20 weeks, as remember, the placenta barrier will be smaller. Okay, or will only be consisting of 2 layers. Then you have more and more amniotic fluid that would surround the baby. So what are the functions of amniotic fluid? Is that it will help to protect the baby. So it absorbs jolts. It will prevent adherence of the embryo to the amnion. So it makes sure the embryo does not stick to the amniochorionic membrane. Okay, it allows room for fetal movements, and it will assist in regulation of fetal temperature. So if the mother is in a cold area, okay, so the only thing that separates the fetus from the outside environment is just the skin, the abdominal wall, and the uterus. Okay, but this one it helps to provide another layer of amniotic fluid to ensure that the fetus is always in a nice the 7 degrees Celsius temperature. Okay, and also allows room for fetal movements. Okay, so when you have fetal movements, you're able to actually grow the musculoskeletal part of the baby's more. Okay, if the mother of the baby actually has reduced amniotic fluid, and then you have reduction in the fetal movement, then your musculoskeletal system does not grow as nice. You can actually have contracture of the limbs of the fetus. Okay, so you need the space to move the muscles, to move the bones, so that you can grow them better. Right, so volume of the amniotic fluid is replaced every 3 hours, and from the 5th month onwards, the fetus actually swallows the amniotic fluid, about half of the amniotic fluid. Okay, and as it swallows, it will also um, uh, excrete it out through the urine. Okay, so in cases where you have a lot of amniotic fluid, you call it hydramnios or polyhydramnios. So polyhydramnios can have a lot of causes. Okay, some mothers with diabetes mellitus or gestational diabetes mellitus will have polyhydramnios. Sometimes you have abnormalities with the fetus itself, like you have anomalies of the GI tract, the respiratory tract, cardiovascular system, may also result in a lot of amniotic fluid. So there's a lot of reasons of the amniotic fluid can be increased. But there's also a lot of reason how the amniotic fluid can be reduced. Okay, so especially if you have some renal problems in the baby, okay, whether renal agenesis, where you have a polycystic kidney, a genitourinary obstruction, all of this can cause oligohydramnios. And sometimes you can also get oligohydramnios, means reduction in the amniotic fluid because of uteroplacental insufficiency. So if the placenta is not enough to give blood to the baby, you can have oligohydramnios as well, because remember the amniotic fluid derived from the maternal blood. Okay, so all of these conditions can also be detected during antenatal screening, which we'll be talking about it later. Okay, so lastly would be the birth. Okay, so this is all just delivery. You don't really have to know this, but know that during the third stage of delivery or of labor is when you would deliver the placenta. And always remember again to check the placenta, make sure it's not retained. If not, it can cause a very massive hemorrhage. Okay, so I will give these slides to you. It's actually there's quite a bit of it, all this explanation on the development of the placenta that I've covered it in the drawings, but you can read it to further solidify the knowledge that you gained today. Okay, and all this I will pass it to you through the Teams app. All right, any questions? Okay, if there's no question, then maybe we can meet at, how long do you need a break for? Now is 11:20. Is you want 30 minutes break for you to go through everything back again and to take a breather as well? So I'll see you at 11:50.